Hello and welcome to this little video. Now this time around we're going to be using a pair of special triangles to find the cosine values of 30 degrees, 45 degrees, 60 degrees, and sort of using them to find the cosine of 90 degrees, but a little bit more on that later on. We've used these triangles before to use the sine values. If I remember, I'll stick a little link for that video just about now, but I'll certainly try and pop it down in the description. Anyway, let's crack on. So we find the cosine of, let's call it cos of x, by dividing the adjacent side by the hypotenuse. So let's have a look at 30 first. So we've got cos 30 equals, well, let's go up to our 30 degree there. Well, the adjacent side is this fella here. So that's root 3 divided by the hypotenuse, which is 2. And easy as that. Just like it was when we were working out the sines, we are basically making this ratio, making this fraction, something divided by something, something over something, and that's how it goes. If you did it in a calculator, you would get this value. You could also convert it to a decimal, but you've got to remember that these are the sorts of questions which will probably turn up on a non-calculator paper. So you need to be able to either memorize these values or learn how to work them out like this. So next one, cosine of 45. Well, the adjacent this time, we're down here, the adjacent is 1. And the hypotenuse for the 45 is root 2. So we've got 1 over root 2. Now, those of you who have seen the sine video will go, we've got to do a little bit more here because we don't like having roots on the bottom. We don't like having roots as a denominator. We need to rationalize them. And we rationalize the denominator of this fraction by multiplying the whole lot by 1. But not just any 1. We multiply it by root 2 divided by root 2, because anything divided by itself is 1. So that's going to give us root 2 over root 2 times root 2, which is 2. Lots of 2's in that one. And that's the value we want. It's exactly the same as this fella here, but we've got a nicer denominator down there. It's easier to work with. Okay, cos 60. Same again, adjacent. So we're on 60 there. The adjacent is going to be 1. And the hypotenuse is going to be 2. 1/2. If you want a decimal, put it as 0.5. But like I said before, I prefer to keep these as fractions. They're just easier to manipulate. Okay, now, cos 90. This is an awkward one if we're using this method. For starters, let's have a look at where we are. If we're down here using the 45 fella, our adjacent would be 1 on either side, and the hypotenuse would be root 2. Okay, 1 over root 2. But let's look what we've got here. This 90, we've got an adjacent which is 1, and the hypotenuse is 2. Already we're different to what we had down here. But even more, we have an adjacent which is root 3 and a hypotenuse which is 2. You can't have 3 values the same. So for this one, you just have to remember that cos 90 is a nice round number. It's actually 0. Don't try to use these triangles to work out cos 90. If you do, you're going to come unstuck. Just remember, cos 90 equals 0. What I say to my pupils is, this sort of value, it needs to be on a nice little post-it note and stuck on somebody's forehead, so when you pass them every day, you go, oh yes, cos 90 equals 0, and it looks like somebody's face. That's normally a good way to remember it. Anyway, that's all for now. I'll be looking at tangents next time. Take care.